Okay, so for those of you who are just joining or watching the recording, I'm sorry I forgot to start it. You just missed the first couple examples, but I'm more than happy to work with you. If you have questions, just email me. Okay, so now that we've looked at the difference of squares, there's another special case that I would like to identify, and that is called the sum of cubes. Very similar to the difference of squares. This has two terms, each of which is a cube with addition in between them. So by a cube, I mean the same number times itself 3 times equals whatever this value is. And this factors into the root of the first plus the root of the second times the root squared minus the product of my roots together plus my second root squared. I know it sounds really confusing, just write it and we'll do examples.
What does this do?
It allows us to factor this extremely easily. Because if I looked at this the way it is right now, I have no idea how I would factor that without this rule. There would be no way for me to make that smaller. This is factoring. Breaking it up into smaller portions that multiply together to equal that. Okay, so let's do an example. I know this is a little bit rough, that's why we're doing 2 days of this, give you time to process. So I would like to do 8 plus a cubed as my first example. Just like we did on the difference of squares, I would like to identify the cube root of each of these and then use that to build my factors. So what multiplies by itself 3 times to get to 8? 2. So this is 2 times 2 times 2. What multiplies by itself 3 times to get a cubed?
1.
A. A times A times A. Do we all see that? What if I have a huge number here that I have no idea what its cube root is?
Use a calculator.
Use a calculator. There are 2 ways. Well, one way you can do it. You take this number, you put it in your calculator, and you raise it to the 1/3 power. And that will tell you what its cube root is. You're going to have to do that on your homework. There's a couple that are fairly large.
Raise it to the 1/3.
Raise it to the 1/3 power.
Wait, how do you do that?
8, there's an upward arrow, which we call a caret, and then parentheses 1 divided by 3.
I really like that.
Okay, so now that I have my cube roots, I can build my factors. My first factor is a binomial. It just includes one of each of my roots in the same order they're written in the original problem. So the cube root of 8 is 2. The cube root of a cubed is a, with addition in between. Once I've used the root, I get rid of it. So I crossed out one of each of my roots. My second factor is a trinomial, meaning that it contains 3 terms. My first term are my remaining roots put together. So my 2 roots I still had left from the 8 are 2 times 2, and 2 times 2 is 4. My third term are the 2 roots I had left from my second term. A times A is a squared. It's always a plus. And then my middle term is this times this with the opposite sign. So 2 times A is 2A. With the opposite sign makes it minus 2A. And then those are my factors. This is extremely helpful because if I were wanting to solve this, I could set this equal to 0, and I could use the quadratic formula here to find the rest of my zeros. What's wrong?
Is that how you solve it?
That's how you'd finish it out.
I
Yeah.
got the 4.
You got the, okay. So then I had 2 times 2 to make the 4, right?
Yeah.
Then I had the A times A that was left here to make the A squared.
So wouldn't that be on?
No, I still needed this middle term.
Okay.
And this middle term came by multiplying these two together with the opposite sign. So 2 times a is 2a, with the opposite sign makes it minus 2a.
Oh, okay.
This is hard. I know it's hard. That's why we're taking our time with it.
Hey, Miss Duran.
Yes.
So will this be on the test tomorrow, or a quiz?
Quiz on Friday? Yes.
Quiz on Friday?
Yes, quiz is on Friday.
So we're taking 2 days to do this?
This is a 2-day lesson, yes.
Okay, thank you.
Okay, ready for another example? I know we're all super thrilled about this. So happy, right? Okay, next example. On this one, I have 125c cubed plus 27. In order to apply the sum of cubes, I have to ensure that this is actually a cube and a cube together. I know the c cubed works, but I need to make sure a whole number times itself 3 times equals 125. So using your calculators, if you don't already know what it is, find the cube root of 125. If it's a whole number, I'm good to go. We will, yeah, but I want one at a time. I don't want to get overwhelmed.
Cute.
What'd you get, Sam? 5. 5 times 5 is 25. Times 5 is 125. So this one becomes 5c times 5c times 5c. I have the 5 3 times and I have the c 3 times. Are we all okay with that? Who said what?
What?
Hello?
Sound like a cat.
It's not like Alex.
Okay, so I found the cube root of my first term. I need to do the same thing with the 27. I need to ensure that it is in fact a cube. So I need to find its cube root and see if it comes out to be a whole number. Does it? Yeah, 3 times 3 times 3 is 27. Once I have my roots, I can build my factors. My first factor is a binomial, meaning it only contains 2 terms. And those 2 terms are one of each of my roots in the same order with the same sign. So I take one of these 5c's, and that's my first term. I take one of these 3's, and that's my second term. And I have addition happening in my original problem. Build the rest of that, please. Christina has. Okay, Brandon, talk me through it.
Okay, so I said 5c. You multiply the multiple, right?
Yes.
5c times 5.
Yes, which is 20.
5c squared.
There you go. Okay, so he recognized that 5c times 5c gives me 25c squared, which is the first term of my second factor, sorry. Then what do I do?
You go 5c times 3.
Okay, so he went to the second term, and he did 5c times 3 is 15c, with the opposite sign is negative 15c. And then what about my third term? Which is 9. And then I'm finished factoring.
That's our answer.
That's, for now, that's your answer, yes. That is your factored answer.
Is that what we did?
If I ask you to solve it, then you'd have to do the quadratic formula to finish it out. But if I just say factor, then you're good here.
We're gonna go over to.
Yes, we're slowly building our way up to it.
Are we gonna do that tomorrow?
Probably. Probably a little bit of both. Okay, any major issues with that? There is not just a sum of cubes rule. There's also a difference of cubes rule, which is the exact same, but with subtraction happening instead of addition. So the example I would like to start with, or actually, let's just write the rule. So the same thing works here. I take one of each of my roots, and those form the first factor with the original sign in the middle. So So this one is subtraction, so I have subtraction happening between each of those roots. Then I take what's left from my first factor and multiply it together. My third term is what's left of my second factor multiplied together. And then my middle term is a times b with the opposite sign. So right now I have a times a negative b is a negative ab. The opposite sign makes it positive ab. So the exact same concept, just with opposite signs here.
Also just a positive number.
What are you confused about?
Oh, wait, no, I didn't figure it
Okay, it's literally the exact same as before, except I'm starting with subtraction instead of addition. So let's do an example. Let's do a cubed minus 27. Just like before, I need to break this down into my cube roots. A times A gives me a cubed. 3 times 3 times 3 gives me 27. I take one of each of those factors to create my binomial. So I take an a and I take a 3 with subtraction in the middle. Then I build my trinomial. I take what's left from my first term. So a times a gives me a squared. I go to my third term, which is what's left from my second cube. 3 times 3 is 9. And then to find the middle term, I multiply these two together and take the opposite sign. So negative 3 times a is a negative 3a. Opposite sign makes it positive 3a. How do we feel there? Is it getting easier the more we do it?
Yeah.
Okay, that's all I look for
out.
here.
So is there a difference for some squares?
No, that is impossible. You'll get imaginary numbers there. Of course, come on. Let's go ahead and do one more and then we'll move on to the next part. So let's do 64a cubed minus 125c, oh gosh, to the 6th. Oh, it's pretty. Let's focus on the first term first. So I know a times a will give me a cubed. What number times itself 3 times will give me 64? 4. So that means the root of this is 4a. Then I go ahead and move on to my second term. I have 125c to the 6th. The 125 part is fairly easy, correct? Because we know 5 times 5 times 5. So I need to think about c to the 6th and how I can evenly break that up into 3 factors. C squared each time. So 5c squared is the root of 125c to the 6th. And then I build my factors just like normal. Is everybody okay with how we did that? Yes, Bolt. I took 6 and I asked myself, how can I break 6 up into 3 even parts? So 2 and 2 and 2. Okay, so now I build my factors. I pull one of each of these for my binomial. Then I go ahead and I build my trinomial factor. 4a and 4a is 16a squared. I'm going to move on to the second term because I want to go in order and make sure I leave enough room. 4a times a negative 5c squared. It'd be negative 20ac squared. However, we need the opposite sign. So it becomes positive 20ac squared. And then I do 5c squared times 5c squared to get 25c to the 4th as my third term. And then I'm done.
I feel like I'm gonna be able to do this.
And then I'm gonna get to the homework and I actually made the homework fairly straightforward for this, so it shouldn't be terrible. And it is 2 days, so you can look at the homework today and then come to me concerned tomorrow. That's fine. Okay, any major issues with this? If the numbers do not come out to be whole numbers, then I cannot apply the difference or sum of cubes. So we only use that if they're whole numbers, and it will make factoring easier. If I'm asking you to factor it, we just have to find another way to do it.
Oh, so we have.
Will there be questions like that?
On your homework, no. On a quiz, I might ask you, can we use this? I don't know. You never know. Okay, so there are a lot more examples on here that you can work with that are difference of squares. I don't think we need to go through all of them. I'm sorry, difference of squares, sum of cubes, and difference of cubes. I don't think we need to go through all of them. So I'd like to introduce the next way of factoring, because there is more than one, of course. And this is called factoring by grouping. Xavier should be a pro at this one.
Sure.
So let's say I'm starting out with 4x cubed plus 2x squared minus 2x minus 1. And I would like to factor her. I know, you're going to think you can't do it. That's okay. Okay, so when I say factoring by grouping, I literally mean we're going to group some of these together and pull out common factors. That's it. I like to group them the way they stand right now. So I'm going to put these two terms together, and I'm going to put these two terms together. I like to rewrite it so it looks a little bit nicer. So I end up with 4x cubed plus 2x squared plus negative 2x minus 1. Since I grouped them, I'm going to look at each group individually to begin with. So looking at these first two terms, 4x cubed plus 2x squared, what can I take out of both of those terms? I'm looking for the largest thing. 2x squared, right? I can take a 2 out of both the 4 and the 2, and I can take an x squared out of both the x cubed and the x squared, correct? Okay, so when I take it out, I just put it out front. 4 divided by 2 is 2. X cubed divided by x squared is just x. 2x squared divided by 2x squared is just 1. So that first grouping turns into 2x squared times 2x plus 1. What do you think of both?
What did you just do?
I took or factored out a 2x squared from each of these.
Oh,
I'll show you in a minute.
Why did it so? Why?
I'm going to show you. Okay,
What happened to 2x?
that's a 2x. This is still over here. I haven't touched it yet.
I'm not talking about that. You took
This
2x
one?
squared out of both of those. That would have left 2x. And that right?
Yeah, 2x right here.
I hate it.
2x squared divided by 2x squared is 1.
Oh, okay.
Yeah, we can't just get rid of it if it cancels out. It just becomes a 1. So now that I have this one, I look to my second grouping and I ask myself, okay, what can I take out of this group that's going to leave a 2x plus 1 in there? Negative 1.
So we have to get the exact.
We want what's inside the parentheses to be the same. So negative 2x divided by negative 1 is just 2x. Negative 1 divided by negative 1 is positive 1. You don't need a plus and a minus here. I just like to show that we're still adding or subtracting them. So this becomes 2x squared times 2x plus 1 minus 1 times 2x plus 1. My goal is to have what's inside those parentheses be exactly the same because that becomes my common factor. So now this factors beautifully into what they shared, which is the 2x plus 1, times what I pulled out put together.
What do the boys have?
It's gonna be fun on the recording. Okay, so really take a second to look at it. I pulled out what they had in common, and that became my first factor. My second factor then, I took the values that I initially pulled out, and I put them together in one factor with addition.
Oh, so you get rid of the negative. You switch the sign.
Nope, didn't switch any signs or anything.
But it's in the negative
Wait.
one.
Yeah, I have a -1 right here, because I pulled a -1 out of that second parentheses. What do you think, Bolt?
Well, what did you do? What did you
Oh,
do
okay.
with the numbers?
I took these two and I just put them here because it became my new common factor.
Yep.
And then I took what was originally out front and I put it together in my second factor.
Oh, I thought you like multiplied them
No.
or something like
Nope, I just pulled them out and put them together.
They don't, they're not exactly.
Oh, why is there only one?
I pulled out a common factor, so if I had like 15 and 20, I could pull out a 5, and that 5 only exists once.
Wait,
So it's just like this was multiplied into that.
so are these supposed to equal the same thing?
I do not want them to equal the same thing. What I wanted to do was I wanted to break this down into something that was a lot more reasonable to work with, and I did that.
Oh, so that's,
It's a lot easier to try and factor these or trying to find the zeros from these than it is from this. That's the whole point here.
oh, so now we have to do something.
So now if I asked you to solve, you would set this equal to 0, you'd set that equal to 0, and we solve. We're not there yet. I'm just factoring here.
Oh, okay, so that's all for that.
Yeah, this is all for the factoring. This is where we would stop.
So we're gonna be able to do this 3 different ways on the homework. We're gonna ask the factor.
Pretty much, yeah. Kind of fun, isn't it?
So
Yes.
we could do the super easy one up here.
If it applies, yes. It won't always apply.
Yeah.
Like none of those special cases worked for this polynomial. None of them. So I had to find another way to do it.
Wait, so you can use factoring by group?
Almost. It usually works on a lot of them. And on your homework, there's a group where it's going to work on this. Let's do another one and we'll walk our way through it again.
Literally, we're like, so bad.
I saw it.
Good job.
I know.
Okay. So I have 10AB minus 6B plus 35A minus 21. We're going to factor by grouping again because I have no special case that's going to work for this. When I factor by grouping, I know. I'm going to put my first two together and my second two together. That's fine. Go for it. Okay. So I put these first two terms together and I put my second group together. You can rewrite it if you want to. I'm not going to here. I'm just going to ask myself, looking solely at this first grouping, what can I take out of both of those terms?
A 3. No.
Okay, let's start with the numbers. What's the biggest number I can take out of 10 and 6? 2. What's the biggest variable I can take out of A, B, and B? B. So I'm going to take a 2B out.
Oh, out of
When I
that.
do, I just divide it. 10 divided by 2 is 5. AB divided by B is A. I do the same thing with the negative 6B. Negative 6 divided by 2 is a negative 3. B divided by B is just 1. So I just leave it negative 3. Are we okay there?
Yes, we are.
Anybody super confused? Okay, so now I do the next one. My goal is to make that parentheses also end up with a 5A minus 3 in it. So looking just at that first term, what can I take out to make that equal a 5A? A 7. It just so happens that when I take a 7 out of this, it's also going to work. So I take 7 out. 35 divided by 7 is 5A. Negative 21 divided by 7 is negative 3. Now my parentheses are the same, so I can factor this and be done. So I take what they share, which is the 5a minus 3. And that comprises my first factor. My second factor, I take what I pulled out, and I put it together. And I'm done. First one always does.
So you get rid of one of those.
Sure, you can think about it like that. I take the two since they're the same, I just put them together as one.
Numbers are fake.
Why don't you square it? Like if there's two.
Why am I not what?
Like where wouldn't you square it?
Because I'm not multiplying them together, I'm pulling out a common factor.
But I-
So when I pull it out, I only have to pull it out once, even though it's present two places. Yeah. Okay. How do we feel about this?
It's okay.
Decent, not terrible. So if I ask you to do one on your own, you can.
Yes.
Awesome, let's do it. It wouldn't have mattered what you said, Brandon. You still would have done it.
Well, if we said it was bad, it would have made us do it.
Yeah, I'm gonna have one day on mine, so my back's just hurting so bad, but then I'm gonna be looking up like this.
I'm gonna start calling our weed next week. Like,
Okay, so this polynomial, I have 8r cubed minus 64r squared plus r minus 8. I would like you to factor by grouping.
which one's grouping?
The ones we've been doing.
Megan, I love you so much. Oh, I'm sure you do. Two, can you take out a, wait, I can't. Oh, no, I'm just.
You guys could do
Brandon, talk me through the first step.
Okay, I got this. You gotta take 8r squared or 8r minus 64 squared and put it in parentheses by itself.
Okay, I really hope you all just heard what Brandon said. Say it again.
You gotta take 8r cubed minus 64r squared and put it
Okay, then what?
and do the same thing to r minus 8.
Same parentheses or different parentheses?
Different.
Perfect. Okay, now what?
Now you figure out what divides by 8 and 64 8r squared.
Okay, so he recognized that I can take an 8 out of both 8 and 64, and I can take an r squared out of both r cubed and r squared. When I do, 8 divided by 8 is 1. R cubed divided by r squared is r. Negative 64 divided by 8 is negative 8. R squared divided by r squared is just 1. Looking at that second parentheses, what do I have to take out to make it equal r minus 8? Nothing. So we just say that we took a 1 out when it comes down to it. So this just becomes plus. You can put a 1 here if that makes sense to you. 1 times r minus 8, and now I can factor. So the r minus 8 is my shared factor, and then I pull what I took out of them and put them together as my second factor.
Would it still be the same if you left like 8r squared? That we didn't like put the 1?
No, you have to have the plus 1 in there. Yeah, if you don't, then it's not finished. It's not what we started with.
Wait, no.
Yeah, we always have to take something out of the second one. That was a great question, Addison. In theory, we didn't take anything out. So if you had left this as just 8r squared, we'd be missing the second half of this polynomial. Okay, so if you can't take anything out, we just say that when we divided it out, it was a 1, which meant it stayed the same. You just hit your head on that. You okay?
Yeah, I'm fine. It's gonna be in the video.
That's okay. Every time Keaton moves, it's in the video too. It's fine. Okay, do we need another example of those? Are we for the most part okay? Oh my gosh, I totally meant Reese. I'm sorry. It's fine.
You're gonna have to watch the
How's
video.
Every time he hits the desk, it shakes.
Oh.
It's super fun. Okay.
What happens if it's like not the
I
first
sit in
time?
front of him in Spanish.
You know, Flora will record the videos but not post them.
What?
I'm talking about
What?
Flora will record it and then he won't post it, or at least I'll check and he hasn't posted it. I'm like,
Okay.
There's a miss. I do not have any more pencil left. It is on thin ice. I thought I could.
Victoria,
Yeah.
what happens if you take out like something the first time and it's not the
This is
same?
the fun life. I want to.
I'm a little confused by the question.
Oh, I know what you mean. Okay.
So,
The
like,
first time that you factor out the second problem, what if it's not the same as the first?
then factor by grouping doesn't work. Yeah, that is not possible. So you'd have to use something else. Yeah. Sometimes there's a lot of trial and error in this. That's okay. Okay, the next part of our notes is just kind of a compilation of everything that we've done. Some of this is going to be able to use those special cases we talked about. Some of it's not. Some of it's just going to be basic factoring or pulling out common factors, and that's okay. The key here is I need to factor these as far as I can possibly go while staying in the real number system. Which means I can't have any I's yet. I'm not ready for those. So if I'm going to get an imaginary answer, I can't factor and I need to go back to where I stopped. Correct, right now. Right now, no. Okay, so let's start with the first one. 3y to the 5th minus 75y cubed.
I have a question. On the test, is it gonna say like what method to use, or is it just gonna be like?
I may or I may not.
I'm gonna end up going through like every single method, like the last one I don't do is gonna be the one, and then there goes a few minutes.
Yeah.
Quick question. Can I use the difference of squares rule on this? No. Can I use the difference of cubes? Can I use factoring? Because I do not have 4 terms, so I wouldn't be able to equally distribute this, which means I have to use something else. As I'm looking at this, do I notice anything about both of my terms?
They both divide by 3.
I can take a 3 out, and I can take
Three.
a y cubed. Yeah, because this has a y to the 5th, and that has a y cubed. I always look for the largest thing I can take out of the number and the variable. So I can take a 3y cubed out. 3 divided by 3 is 1. Y to the 5th divided by y cubed is y squared. Negative 75 divided by 3 is negative 25. Y cubed divided by y cubed is just 1. Y squared minus 25 is not factored completely yet because it still has an exponent larger than 1. But what do I notice about y squared minus 25? Difference of squares. Y times y gives me y squared. 5 times 5 gives me 25. So that's going to factor into what?
5 plus 5
Yes. So what I have now is 3y cubed times y plus 5 times y minus 5. Now I'm as factored as I can go. What's your question, Brandon?
Oh, that's not hard.
Oh, it was.
I did the y times y and y.
You broke it down, like, with the arrows?
Yeah.
No, this one was the difference of squares. It wasn't a y cubed, so I couldn't do the cubes one. But I did the difference of squares, which was the first one.
Oh, okay.
This would be as factors I can go, yes. I have a question for you, though. When I think about being factored completely, I think about no exponents present at all. But I still have a y cubed here. Why is that okay? What can I break y cubed down into? Y times y times y, correct?
Yeah.
There's no addition or subtraction happening after it, so it's okay to leave it like this, because writing it like this just seems kind of dumb. I'm not gonna lie, like, it's just not cool. What else is interesting about this is that when I take the 0 for this, it's going to occur 3 times in my polynomial. So that's another thing that we learned from this, is that any exponent applied to my factor is how many times that 0 exists. We'll get to that. So if that confuses you, that's okay, but I wanted to throw it out there so you have time to process.
I have something for you.
Yes, I love off topic.
If you do 1y plus 1y plus 1 equal 3y.
That would not be y cubed. No, we only get that if all of them were the same. So it could be like y cubed plus y cubed plus y cubed. But that's the same as this, pretty much. Yeah, it's not worth it to do that. Girls, are we ready? We're gonna do another one, and I think we're gonna pause then, because I don't want to overwhelm your brains. It might be a little late, but I don't want to. We might do 2, actually, now I'm thinking about it. It's over.
It's already over.
You're over it, right?
We did this in one day.
I wouldn't do that to you.
I would cry.
Looks
I'd
like
leave her.
Can't we just do the one thing with the grouping?
Grouping. Who else thinks we can group on this one? We can, because there's 4 terms, and that's really the only way I can approach this right now. So when I'm grouping, I'm going to group the first terms, I'm going to group the second group. I'm going to rewrite this because there's subtraction here, and it looks a little bit nicer when I rewrite it. So I'm going to have x cubed minus 3x squared plus negative 16x plus 48. Bolts. What do I do next?
Well, for the first parenthesis,
Okay,
you can take out x.
I can take out an x squared, which leaves me with x minus 3. Then what? Samantha, what do I do next?
You need to factor the second created to equal parentheses.
Okay, so what can I take out of negative 16x plus 48 to make it leave an x minus 3? Absolutely, 3 times actually.
Okay.
Okay, maybe I should think about it a different way. If you're lost, that's 100% okay, because this is a lot to think about. So I like to break it down. I like to ask myself, what can I divide out of this to make it equal that? So I have a negative 16x, and I want it to equal x. What can I take out of it? Everybody, come on. Negative 16, that's the only thing I can take out of it to make it equal an x. So I'm going to take out a negative 16. When I take it out of this, it also comes out of that. Negative 16 divided by negative 16 is just 1x. 48 divided by negative 16 is negative 3. By chance, it worked out. I got an x minus 3 in that second parentheses, which is what I wanted to happen. Yes, Samantha, sorry. I'll come to you in a second.
Sorry, what happened if you don't do
Then we need to try a different approach. Graded. Okay. It's not always going to work out. As I was telling, I think it was Addison, this is a trial and error kind of thing sometimes. You might think that grouping's going to work perfectly, and then it doesn't. That's okay. We just start over and we try a different aspect.
So what happens if you're grouping and it doesn't work?
Then we try something else. We will learn more things.
Okay.
We're not done yet. Okay, so now that I have it grouped, I can go ahead and write my factors. My first one is what they have in common, which is x minus 3. My second one is what I took out of each of these factors. So x squared minus 16.
you have to write it that way? I think the x squared minus 16 first.
It doesn't matter. Order doesn't matter for multiplication. Am I finished? Oh, goody. Thank you. Jalen, say that louder.
X squared minus 16 is first.
Okay, I'm not finished, first of all, because this one's linear, but this one isn't. So I have an exponent here. So I need to see if I can finish factoring it. And I actually can because this is a difference of squares. So what number multiplies by itself to get 16? 4. So this is going to factor into x plus 4, x minus 4, and then I will be finished factoring. So I have x minus 3 times x plus 4, x minus 4. The next step, if we were finishing this out and finding our zeros or our solutions, would be to set each of these equal to 0 and solve. You are dismissed. Have a wonderful day.
Oh, that's not far.